Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit. Today we're going to be talking a little bit about geometric probability. Now, whether you've actually studied probability or not, we probably already have a good sense of regular probability. And I want us to think about this in terms of want divided by total. So what do I mean by this? Well, let's take a look at some very simple examples, even though you can do more complicated ones with the same idea. Right? What's the probability that if you flip a coin, you get heads, right? So you flip a coin, we want the probability that you get heads. I think everybody can easily say this is 1/2. But I want to think about this as want divided by total, right? There is one thing we want to get heads, and there are two total outcomes here, right? Either heads or tails. We're assuming it's a fair coin, all of those things like that there, but this is our general want divided by total, this ratio of the total number of outcomes to the number of outcomes we want. Now, this can work similarly if we kind of roll a die and we get 6, right? Now there are 6 outcomes. This is a 1 in 6 chance. Same idea there, 6 total outcomes, one way to get what we want. Right? If this was something like roll a die and get an even number, then there might be 3 out of the 6 outcomes. And you can do more complicated questions, dealing a deck of cards, right? All with the same strategy. You're counting how many ways there are in total and the ratio to what you want. Now, these are simple examples, but I want us to keep thinking about that same want divided by total when we think about geometric objects, so lines or shapes or things like that. So when choosing things uniformly, calculating probability as a ratio like we've seen, want divided by total, this can also work when we measure things in terms of length or area. So this is where the geometric probability comes in. And even if this idea seems a little bit weird, I'm sure you're kind of already comfortable with this with some basic examples, right? So suppose we pick a point randomly, right, uniformly in this square. And I say, oh, I want to cut this square in half. So I draw a line in half, and I want to know the probability that we pick something above this line. Right? Well, pretty obviously you would say, even with this original logic, there's 2 pieces, and we want one of the 2 pieces, so this is a probability of 1/2. But I want you to think about that here in terms of area. The area we want is 1/2 of the total area. And we can do this with length or even volume in advanced cases as well. But this is another important way of calculating probability there. Let's take a look at one example of this. So this will be kind of a number line example. So we want to be measuring stuff in terms of length. So we randomly choose a real number x on the number line from -5 to 10. So we have a long number line here, right? We have -5 on one end, we have 10 on the other end there. So this entire thing is of length 15. Right, so right off the bat here, if we start writing down our probability right away even, right, we can have want divided by total, and we see that, okay, we're picking this on a number line, and we're picking real numbers. So just to kind of make this clear, this means you could pick the number 0, you could pick the number 2.6, you could pick the number pi, right? Anything on there. Doesn't have to be an integer, doesn't have to be a fraction even. Any number on this number line between -5 and 10. So we choose a number x, and we want x squared to be greater than 16. So if we start thinking about that, if we square our number and it needs to be bigger than the number 16. Well, how can that happen? Right? This tells us that either x itself is bigger than 4, so the number is bigger than 4, or x is less than negative 4. So I don't want to worry too much about having kind of exact dimensions and things like that on our picture here. But, right, we could say here then we have our important point negative 4 on one end. We have our point 4 over here that is also an important point. And if we start thinking about what we want, right, we either want to be in this interval here or in this interval here. So if we look at how long those are, remember we want to measure stuff in terms of length. -5 to -4 has a length of 1, right? So this is length 1 right here. 4 to 10 has a length of 6. And putting those together then, we see that, okay, 7 in terms of length of the 15 length is what we want, divided by the total. So this is our probability. So you just do this like you're counting almost, except instead of counting, you're measuring lengths. So our probability is 7 out of 15. There's a 7 out of 15th chance that if you pick this number x, x squared is bigger than 16 in this scenario. Thank you guys for watching this week's video. Check back each week for a new video in 2021. And as always, you can put some of this knowledge to the test at ziml.areteem.org. So hopefully I'll see some of you guys there. Have a great week. Goodbye.